going to talk about slope-intercept form today, but before we do that, let's make sure we understand the meaning of slope and the intercept. And so the slope of a line is really kind of like its slant or how steep it is. And the slope is written, if you kind of think of a line that's just drawn here, the slope takes into account how much to get, let's say, to get from one point to another point that would fall on a line. It's how much are you going up in reference to how much are you going over to get to that other point. If you were to go up a lot and over just a little bit, well, that would kind of create a very, very steep line. Whereas if I'm only going up a little bit and over a lot, then that line would be very flat. And so that slope is kind of determining that relationship between the rise and the run to get from one point to another point on your line. Okay, so if I'm kind of counting how much do I have to go up, like looking back at this original one, how much am I going up? Well, anything that's up and down on your graph is your y value. And so to find out how much I'm going up here, I would just subtract my y values. So to find the slope, we actually have a formula, and for whatever reason, we use an m to represent slope. So the slope is equal to, and I'm going to subtract my y values, so our formula is y2 minus y1. And that 2 is just a little sub number to distinguish it from the other y, and so you have a y2 and a y1 there. Make that y a little bit bigger. Okay, so that's going to be the change in the y's, how much your rise is right here. How much you have to go up. Sorry, that's messy. Okay, and then I'm going to look at how much do I need to go over. So your left and right motion on your graph is always your x values. And so the slope is actually a ratio, so it's written as a fraction, big fraction here. The rise, or the change in the y's there, over the run, which is the change in the x's. So it's going to be an x2 minus x1. So I'll subtract the x values, and that will give me my run, or how much that I'm going left and right on a graph. Okay, so it's a great little formula, one that you would definitely need to know. You'll probably use it enough that you're going to get to know it, but make sure you can do the slope formula without having to look at it in your notes. Okay, so let's say that I give you a couple points that are on a graph. Okay, so let's say it's 2, -3, and the point 7, let's say 7, 2. Okay, so if you think of on a graph where those points would be, and I'm just going to estimate here, but over 2, down 3. All right, so there would be my first point. My other point is over 7, up 2, somewhere over here, and so I'm looking at what is the slope of this line. So I'm counting my rise and my run. But I'm going to use my formula to do it because the reality is graphing takes a long time. It's a nice visual and it helps us at the beginning, but in the end we just want to know what are we doing with these numbers so that we don't have to graph every problem. And so to find the slope of this line, I'm going to take my y's and subtract them. And it does not matter at all which y I start with. I know it says y2, so that might make you think you have to use the second point as opposed to this first point, which we can, that's fine. It doesn't really matter. It'd be a 2 and then minus the y in my other point, which is -3. So 2 minus -3. Which really, remember, if you got a minus minus, it goes to plus plus. So that's going to get me a 5. And then I do the same thing with the x's. Now remember I said it didn't matter which point you started with. I could have started with the -3 and subtracted the 2. But whatever you decide to do with your y's, you have to be sure to keep it in the same order when you do the x's. So since I started with the second point, I started with the 2, then that means I have to start with the 7 when I do my x's. So it'd be a 7 minus the other x value is a 2. And so I have 7 minus 2, and that's 5. Well, how beautiful is that? Okay, so always, I kind of like to keep my slope a fraction. I don't change it to a mixed fraction or anything. I like to see my numerator is my rise, and my denominator is my run. But if it is a fraction that would reduce, we would certainly want to reduce it. And a 5 over 5 is just 1. So the slope is 1. All right, so that's what our slope is. We'll be using this formula to find slope, or maybe if it's already graphed for us, we can use a graph to count that rise and that run. But again, most of the time we'll probably try to use our formula rather than having to graph it. The other part of slope-intercept form, we've got the slope. The other thing that we need is the y-intercept. And that's pretty quick and easy. You basically are just talking about where does your line cross your y-axis. And so maybe you have a line that crosses the y-axis right here and it comes down and looks something like this. Well, your y-intercept is this y value of your point. So maybe in this case it's at 3. So the y-intercept is equal to 3. Sometimes you can tell that from a graph. Other times you're going to have to go graph it because you know what the y-intercept is. So that's quick and easy. Just know that when we talk about slope-intercept, we're talking about the y-intercept. Slope-intercept form is just a very common format that we write linear equations in algebra. And so it's just a way where you put your y all by itself on the left side of your equation, and in the process of doing that you have everything else over on the right side. The m is the coefficient that's on your x, and that m is actually the slope of your line. And then you'd have an x, and then it says plus b. B is just your constant, whatever your number is that's left in your equation, and that b represents the y-intercept, or where your line will cross the y-axis. So if you have an equation that's written in slope-intercept form, you can pick out your slope and your y-intercept and go graph those very quickly. That's one of the great features of slope-intercept form. So let's say that you have an equation, something like y equals 2/3 x minus 5. Okay, if you have this equation, then you should be able to pull out what your slope and your y-intercept are. So my slope in this equation is the coefficient that's on my x, and so that would equal 2/3. That's the number being multiplied by x. The y-intercept of this equation would be, well, it's supposed to be a plus b, but since it's a minus, then my y-intercept is actually going to be a negative 5. So then my line is going to cross at negative 5 on my y-axis. And so just a real quick sketch here of what that would kind of look like. So then I would know if I was going to try to graph this, remember this is my x-axis, this is my y. So it crossed the y-axis at negative 1, 2, 3, 4, 5. Okay, so it would end up crossing the y-axis right there. And then my slope, recall, is my rise over my run. So from that point, I could rise 2. There's 1, 2. And then run 1, 2, 3. I'm just kind of estimating that. And then I would have another point that would fall on the line. And then I could do that a few times to kind of make it a little bit more accurate. I could rise 2, run 1, 2, 3, get another point, and once I get a few points, then I can graph my line. So it's real quick to graph lines if you can put them in slope-intercept form. Okay, let's try another example. But this one I'm not going to give it to you in slope-intercept form. Let's say it's 2x minus 7y equals 9. Okay, it's still a linear equation because it has this x and y in it, but it's not in slope-intercept form because my y is not by itself. So then, to put it in slope-intercept form, you just work on isolating the y. And you start by moving the things that are farther away from that y. So this 2x I'm going to get rid of first. And since it's a positive 2x, I'm going to subtract 2x on both sides of the equation. Now, that works very nicely to cross that 2x out, and I have left a negative 7y equals, and over here on the right side I have a 9 minus 2x. Now that's not 7x. These are not like terms. I can't really take a 9 and subtract a 2x. They're not like terms. And so I just leave them separate from one another. But rather than writing it as a 9 minus 2x, remember up in slope-intercept form, you kind of like to have your mx and then your b. So I'm going to write my negative 2x part first. Notice that I kept the negative on the 2x. And then the 9 is positive, so it stays plus 9. Okay, so that's your first step, is to move the x term to the other side. And then the next thing I need to get rid of is this negative 7. And so I'm going to divide everything by negative 7. Okay, so that gets rid of the negative 7 there, and I end up with a y equals, and I have this negative 2x divided by negative 7, and typically what we'll do is just kind of pull the number stuff out in front. A negative 2 divided by a negative 7. It doesn't divide very nicely, but that's okay. I'm just going to write it. Remember, negative divided by a negative is actually going to be a positive 2/7 x. And then my y-intercept isn't very pretty either, but that's okay. I'm going to call that a minus, since you got a positive divided by a negative, 9/7. Okay, so then I'm kind of out of room there, but if I were to then look at this equation, it's now in nice slope-intercept form. The slope would be 2/7, because that's the coefficient on the x. And the y-intercept would be negative 9/7. So if I were to graph that, it would just cross kind of at an ugly spot on my y-axis, and I would just have to estimate it. Okay, most of the ones that'll have you graph, you'll probably have a decent looking y-intercept, so you have something to work with. The slope doesn't matter so much because it's just your rise and your run, and so you look at the numerator and denominator kind of individually. So now that we know what slope-intercept form is, let's practice trying to write an equation in slope-intercept form. Now, I'm going to be giving you different information, but regardless of what I give you, you should be able to get it back to slope-intercept form. So let's start off with something pretty basic. Like, what if I tell you the slope is 3/4? Let's make it a negative 3/4. All right, and I tell you that the line is going to go through the point 0, 9. Could you write that equation in slope-intercept form? Well, remember, I'm shooting for y equals mx plus b, and I know that my m is negative 3/4. So that's pretty easy. When you write your equation in slope-intercept form, the x and the y are going to stay in there. The m and the b get replaced by numbers. So my slope is negative 3/4 x, and this right here is just a fancy way of telling you the y-intercept. If you can imagine, where would 0, 9, where would that point be? Well, it's over 0, up 9, way up here. Oh, well, if I'm over 0, my y value, that's really going to be my y-intercept. So that makes it pretty easy. Then my y-intercept is just 9. So I put plus 9, and I got it. There's my equation in slope-intercept form. So that's nice when they hand us that much information. Let's try another one. All right, here's another example where they give you a graph and you have to write the equation in slope-intercept form. So again, you're shooting for that y equals mx plus b. So you're going to have to find your slope and replace the m with it, and find your y-intercept and replace the b with it. Okay, the y-intercept is usually the quick, easy one. You just look at your graph and say, where is it touching the y-axis? And it's crossing at negative 2. So then I know that my b value would have to be a negative 2. The slope, not much harder than that. I would have to look at that and just count. I have to have two good points. I was nice enough to actually show the 2 points on there. Sometimes, well, usually the software is nice about giving you the 2 points as well. Sometimes you have to look at your graph closely and see where it crosses. And so in this case, I'm going to start with my point at negative 2, and I got to do my rise and my run. So in this case, to get from one point to the next point, my rise is actually going down. I'm going down 1, 2, 3, 4. So my rise is negative 4. And my run would be to move to the right. So 1, 2, 3, 4, 5. So my run is a positive 5. So then the slope is a negative 4/5. All right, so if you know your slope and your y-intercept, you just go put those in for your m and your b, and you end up with it y equals negative 4/5 x, and then a minus 2 for the equation of your line. Okay, so let's kind of put this all together. Let's see if we can do several things with this equation. So again, it's a linear equation, but notice it's not in slope-intercept form because the y is not by itself. So let's practice that. Let's put it in slope-intercept form. So to get the y by itself, the first thing I'm going to do is move that 7x. So I'm going to add 7x to both sides. That crosses off. I end up with a negative 6y equals, again, these are not like terms. 18 cannot be added to 7x. We just leave them separate. But I do like to have that mx and then the b, so I'll put my 7x first and then my positive 18 after that. Okay, last time we did that, it was a negative, but that's because we were subtracting that number. So in this case, we were adding the 7x, so the 7x is positive. All right, next step we're going to do is get the y by itself by dividing by that negative 6. But to keep it balanced, you have to divide everything by negative 6. Okay, so then the negative 6's are going to cancel out, and I'll have a y equals, it's a negative fraction, so it's a negative 7/6 x, and then 18 divided by negative 6 is negative 3. Okay, so can you tell me what the slope would be? You should say negative 7/6. Okay, can you tell me what the y-intercept is? And I think sometimes, I mean, you can just write it b equals, but I think the software likes to put it as an ordered pair. And remember that it's a 0 for your x because you're not moving left and right at all, but you are going up or down. Where am I going? What do you think? You should say down 3. The y-intercept is a negative 3. Okay, so then let's take that information and then try to go graph it. Okay, so the first thing I'm going to do is plot that y-intercept on my graph. Over 0, down 3. It's crossing the y-axis at negative 3. Okay, then from there, the 7/6 is my slope, and I'm going to count my rise and my run. Now I kind of purposely stuck that negative out in front because it doesn't really matter if I write it as a negative 7/6 or if I write it as a negative 7 over a positive 6 or if I write it as a 7 over a negative 6. All of those are a negative slope, and it doesn't really matter how I work through that. You kind of have to commit, though. Are you going to put the negative on the top or are you going to put it on the bottom? You cannot put it on both because that would make a negative divided by a negative a positive slope. So don't do that. You just have to decide, do you want to put your negative on the 7 or your negative on the 6? Okay, so I'm going to go ahead and I'm going to show you how it works both ways, and you'll see why it doesn't really matter. So let's say you do this one first. So from that point, my y-intercept, I'm going to rise negative 7. So that means go down 1, 2, 3, 4, 5, 6, 7, and run 1, 2, 3, 4, 5, 6. There's my point. Okay, if you had happened to choose the other way where you put the negative on the 6, well, that just means that from your y-intercept, you would have gone up 7 instead of down 7. So 1, 2, 3, 4, 5, 6, 7. And your run would have been a negative 6, which means you have to go left. 1, 2, 3, 4, 5, 6, right there. Notice that those points line up. It wouldn't have mattered which one you plotted, you're going to end up with the same line. Okay, so then go ahead and connect your points. And there's the graph of your line. Okay, and this was the last thing that I wanted to talk about because there were some special cases in this lesson where your lines weren't nice slanty lines that had some sort of rise and run slope. What they actually were either horizontal lines or vertical lines. And those are special because they only have one variable in them. If you look at their equation, they're not going to look like they're in y equals mx plus b form. There's only going to be a y, or there's only going to be an x. All right, I have a little trick that I use to remember which one's which on that, because there's several things we're going to talk about here. And so it's just called Hoy-Vux. Hoy-Vux. Okay, the H stands for horizontal. So I know that if I have a horizontal line, the slope actually is 0. And their equations only have y's in them. So it's going to be a horizontal line. It's going to look something like y equals, I don't know, y equals 4. And that's what your equation looks like, which means that you're going to have a horizontal line, and it's going to cross the y-axis at 4. So it's going to come right through there. It's going to look like that. Horizontal lines have 0 slope, because if you were to try to count your rise and run of a couple points, you wouldn't be going up at all. It would be up 0. And then over, I don't know, 1, 2, 3, 4, 5, we'll say. But 0 over 5 simplifies to just 0. So it has 0 slope. It only has a y in it. It's going to be horizontal. That's Hoy. Okay, so if you can just kind of remember that Hoy. And then the second type are your vertical lines. Can you guess what the V stands for? All right, and then the U means that the slope is actually going to be undefined. We'll talk about that in a minute. And their equations don't have y's in them, they only have x's in them. So their equation is going to be something like x equals -2 or something like that. With only the x, there's no y. Okay, so something like that would look like, well, it's a vertical line. It's going to cross the x-axis at -2. So it's going to look like this kind of a line right here. Crossing the x-axis, so there's your vertical line, and if you were to count your slope, grab a couple points on that line, you'd still have rise. Let's say it went up 2, but it doesn't have any run this time, and it's 2 over 0. Well, you can't divide by 0. If you were to try to even do that in your calculator, you'd get some sort of an error message. It's a division by error, or division by 0 error. And so that's always considered to be undefined. Don't leave it 2 over 0. That's always counted wrong. We have to commit. Is it 0 or is it undefined? And this one would be undefined. So vertical lines always have undefined slope. Equations only have x's in them. Okay, so that was kind of the last thing that was in this lesson. It was kind of a lot of different things, so I kind of tried to touch on everything. Hope this helps.